Ever just, look up at the stars and think,
Hmm.
are we really the only ones?
It's a big question, isn't it? Always has been.
Well, that question just got a little bit spicier, maybe. There's some genuinely fascinating new stuff popping up, hinting at possibilities.
Absolutely, and that's what we're diving into today. For everyone listening who likes to get straight to the point, we're looking at some exciting potential evidence.
Evidence related to alien life, potentially,
Hmm.
coming from some really cutting-edge observations.
Exactly. We're zoning in on the work of Dr. Nikku Madhusudhan. He's an astrophysicist, Indian-British, based at Cambridge University.
Right, and he and his team have been using the James Webb Space Telescope, that big new one.
That's the one.
Yeah.
And they've turned its eyes towards a specific exoplanet, K2-18b.
K2-18b. Okay. And what they're finding there, it's stirring things up.
You could say that it's potentially huge. We're talking possible chemical hints of life.
Okay, so that's our mission for this deep dive then, to unpack what they found on K2-18b, understand why it's such a big deal, and get a handle on Dr. Madhusudhan's work here.
Precisely. We want to give you the clear picture of the significance without getting bogged down in overly technical stuff, just the core story.
Great. So let's start with the person behind it all. Dr. Nikku Madhusudhan, tell us a bit about him.
Sure. So Dr. Madhusudhan, he's leading this research. Born in India, did his undergraduate, his B.Tech, at IIT Varanasi, a top engineering school there.
Okay.
Then he moved stateside to MIT for his master's and his PhD.
Ah, MIT, and his PhD was already in this area, exoplanets.
Yeah, specifically focusing on exoplanet atmospheres. That was back in 2009 he finished that. So he's been deep in this field for, well, over a decade, really focused on what these alien skies are made of.
So not just a recent interest. He's built his career around that.
Absolutely. He did research stints at MIT, Princeton, Yale, top places. And now he's a full professor at Cambridge, specializing in astrophysics and exoplanetary science.
Impressive track record. And I heard he has the specific idea about certain types of planets, hycean planets.
Yes. That's a really key concept he's helped pioneer, hycean worlds. The idea is planets with these thick, hydrogen-rich atmospheres,
Okay.
but sitting on top of liquid water oceans. Potentially vast oceans.
Hydrogen atmospheres and water oceans.
Wow.
And he thinks these are good places to look for life.
That's exactly his hypothesis, that these hycean environments could be sort of prime candidates.
Yeah.
And K2-18b, it looks like it might just fit that description.
Uh-huh. Okay, so K2-18b isn't just any random planet. It fits this specific profile he's interested in.
Correct. It's a potential hycean world, which is why studying its atmosphere is so important to his line of research.
Right, connecting the dots here.
Yeah.
So dedicated scientist, specific theory about hycean worlds, and K2-18b is a prime target. Let's get to the discovery itself, the James Webb Space Telescope.
Yeah.
What did it allow them to see on K2-18b?
Well, Webb is just incredible. It sees in infrared light, which is key for this. When K2-18b passes in front of its star, from our perspective, Webb can analyze the starlight that filters through the planet's atmosphere. And different gases in that atmosphere absorb specific wavelengths of that light. They leave a sort of fingerprint.
Like a chemical barcode in the starlight.
Exactly like that. And when Madhusudhan's team looked at the barcode for K2-18b, they found something pretty startling.
Okay, don't leave us hanging. What was it?
They detected signals suggesting the presence of dimethyl sulfide DMS for short, and possibly dimethyl disulfide DMDS.
Dimethyl disulfide.
Yeah.
Okay, chemistry wasn't my best subject. Why are those particular gases significant?
Right. This is the crucial part. On Earth, DMS, it's overwhelmingly produced by life, specifically marine life. Think phytoplankton, tiny algae in the oceans.
Wait, you're saying the gas they found on this distant planet is made by ocean life here on Earth?
Primarily, yes. It's a major component of that smell of the sea sometimes. While there might be other ways to produce it, the main source we know is biological, from marine organisms.
So, finding that gas, DMS, in the atmosphere of a planet suspected to have an ocean. That's a pretty strong hint, isn't it?
It's a very tantalizing hint. It's what we call a potential biosignature, a signpost that could point towards biological processes. Finding DMS specifically on a potential water world. Yeah, it makes you sit up and pay attention.
I'll say. It's not definitive proof, obviously.
No, absolutely not. Science requires extraordinary evidence for extraordinary claims. There could be unknown geological or chemical processes creating it, but it's arguably one of the most promising biosignatures found so far.
Especially given the context of it being a hycean candidate world.
Exactly. It fits the picture Madhusudhan has been building. Life in these hydrogen-rich ocean worlds might produce specific gases, and DMS is one that's strongly linked to life in Earth's oceans.
Okay, wow. That really puts in perspective. Now, you mentioned he's been doing this for a while. This wasn't his first big study, right? Give us a bit more background on his previous work.
Sure, it helps see the progression. Way back in 2012, he was lead author on a study about 55 Cancri, another exoplanet.
55 Cancri. I think I remember hearing about that one.
Possibly. It got headlines because their analysis suggested it might be incredibly carbon-rich, maybe even, a significant portion made of diamond.
A diamond planet.
Okay.
Yeah, that rings a bell. That's certainly memorable.
Definitely. Shows his early interest in figuring out what these planets are actually made of, their bulk composition.
What else?
Then in 2014, his work involved looking at hot Jupiters, those giant gas planets orbiting really close to their stars.
Right, the really extreme ones.
Yeah, and they were measuring water vapor in their atmospheres. Interestingly, they found less water than some models predicted, which challenged some ideas about how those planets formed.
So he's not afraid to challenge existing ideas based on the data.
Seems that way. And then in 2017, he was involved in detecting titanium oxide on a different hot Jupiter, WSP-19b. That's important for understanding how those planets handle heat in their upper atmospheres.
Okay, so a range of studies: composition, water content, atmospheric chemistry.
Exactly. And circling back to K2-18b, even before this latest Webb finding, he'd studied it. In 2020, his team published work suggesting K2-18b could indeed host water.
So the water potential was already flagged by his team earlier.
Yes, based on earlier, less detailed data. That 2020 study really set the stage, making K2-18b a prime target for the much more powerful James Webb Telescope once it became available.
You can really see the thread, can't you? Building the case, getting better tools, refining the search.
Precisely. Each step informed the next, leading to this potentially very significant detection of DMS and DMDS.
And it sounds like his contributions haven't gone unnoticed in the scientific community. Awards and things.
Oh, definitely. He's received quite a few prestigious awards, things like the EAS Mirac Prize, the Pilkington Prize from Cambridge, the Ayupap Young Scientist Medal, the Vainu Bapu Gold Medal from the Astronomical Society of India.
Okay, so well-respected, recognized work.
Absolutely. These awards reflect the high regard the community has for his research in astrophysics and exoplanetary science.
So let's try and pull this all together. We have Dr. Madhusudhan, a leading expert focused on exoplanet atmospheres, particularly these hycean ocean worlds,
Right.
who has built up years of research.
Yeah.
And now, using the James Webb Telescope, his team detects dimethyl sulfide, DMS, on K2-18b.
And possibly DMDS as well.
Right. And the big hook is that DMS, here on Earth, is strongly tied to marine life.
That's the core takeaway. Finding a potential biosignature like DMS on a candidate hycean world like K2-18b, it's a major development. It really boosts the idea that these kinds of planets' hydrogen atmospheres over oceans are key places to focus our search for life elsewhere.
It really does feel different somehow. Not just finding water potential, but finding a specific gas linked to life processes.
It's a step closer, potentially. Still much more work to do to confirm it, rule out other explanations, of course, but it's incredibly exciting.
It absolutely is. And it leaves you thinking, doesn't it? I mean, just hypothetically.
Mm-hmm.
If life is confirmed on K2-18b, or another world like it, what does that even mean for us? For how we see ourselves in the universe?
That's the profound question, isn't it? It would fundamentally shift our perspective, knowing we're not alone.
Yeah. Definitely something to chew on long after we wrap up here.
Yeah.
Truly fascinating turn in the search.